Good day everyone, welcome back to our YouTube channel. In this video, we are going to look at finding the sum to infinite of convergent geometric progression. Now, why are we specifying that we are going to find it only of convergent geometric progression? For the simple reason that for us to find the sum to something, we need to know what it's getting to. And if it's convergent, then we have an idea as to where the series is going. For the purpose of this video, we are simply focusing on finding the sum to infinite, and we specified that it's only for convergent geometric progression. For the simple reason that an arithmetic progression always diverges, and there's no point in finding the sum to something that diverges. You can't actually find it. Now, this is denoted by s to infinite, so that's another way of saying that. Now we have a formula, and the formula says the sum to infinite is going to be equal to a over 1 minus r. So we basically need our a and we need our r. What is our a? A is the first term, r is the common ratio. Now, how do we find that from here? We first need to do our substitution, starting with q equal to 0, then going to q equal to 1, going to q equal to 2, and then we continue if we need to. But I would advise you to stick to finding only the first three terms, because that will help you find the first term as well as the common ratio, which is your r. Now, to do our substitution, we are going to say, when q is 0, because that's where I should start, because this is where I'm starting, and then I'm going to look at when q is 1 and then when q is 3. Find those three terms, and then I'll be able to get my a, and my r. How do I do that? I'm going to take my formula, this formula, and I'm going to say, I know for this one, it's going to be q is 0, so it's 0 plus 1 over 2 to the power of 0. Plus, because it's a series, we are going to add. Then I'm going to say, this is going to be negative 1 to the power. Now, q is 1, so it's going to be 1 plus 1 over 2 to the power of 1. Plus, the third one is going to be negative 1 to the power. Q is now not 3, but 2, please. So, negative 1 to the power 2 plus 1. And that is going to be over 2 to the power of 2. Now, I've done my substitution. I simply need to solve and see what are the answers here so that I can get an idea of what, not get an idea, but know what my first, second, and third term of this series will be. However, I'm going to say plus, and then I just use that so that I can just show that I know this does not end there. It goes beyond that. Now, what is this equal to? This is negative 1 to the power 1. So that is just negative 1 over 2 to the power 0 is 1, because anything to the power 0 is 1. Then I can see that, this is basically going to give me negative 1 to the power 2. And negative 1 to the power 2 is going to give me a positive 1, because any number that I can see is bracket, whether it's positive or negative. If I power it to an even number, I know the outcome is always positive. And because it's 1 to the power something, I know it's just going to be 1. I can also use my calculator to get that answer. Over 2 to the power 1, that is just 2. Then I come here. What is this? This is negative 1 to the power of 3, because 2 plus 1 is 3. However, because this is a negative number, if I power that to an odd number, I know the outcome is always going to be negative. So I know I'm going to have minus, and it's 1, because 1 to the power anything is just 1 over 4. Plus, it continues. Then I see that, actually this means that my first term is negative 1, my second term is positive 4 half, my third term is negative 1 over 4, and it continues. There's no point in continuing, because I know I only need my a and my r, and this is enough for me to get those. So what does this mean? It means my a is equal to negative 1. Now I just need to find my r. How do I find my r again? Remember, we know this has to be a geometric progression. That is why I can find the sum to infinite of it. So I'm going to say this is my term 1, my term 2, and my term 3. So according to the formula of proving your geometric progression, we know that the term 2 divided by the term 1 should basically give me the same answer as the term 3 divided by the term 2. Next term divided by the previous one should give me the same answer as this divided by the previous one as well. So what is the term 2? Term 2 is 1 over 2 divided by negative 1 should give me the same answer as the negative 1 over 4 divided by the 1 over 2. What is that? 1 over 2 divided by negative 1 is just negative 1 over 2. Equal to, this is negative 1 over 4 times 2 over 1, which is just negative 2 over 4, which is negative 1 over 2. So basically, I can conclude that my common ratio is negative 1 over 2. Why did I need to do that? My formula needed me to know what is A, and it needed me to know what is R, and I cannot just guess that from here. So I needed to find it, and I found the 2. Therefore, I can proudly say, since I know that S to infinity is equal to 1 minus R, I can proudly say, oh, A is negative 1 over 1 minus negative 1 over 2. That is my A, and that is my R. Now, what is that? That is negative 1 over 1 minus negative a half is 1 plus a half. And 1 plus a half is going to give you a 3 over 2 or 1.5, which is 3 over 2. You can get that answer by using your calculator, or if your calculator decides to misbehave on last minute on you or disappoint you on last minute, I'm going to say this is negative 1 times 2 over 3, which is simply negative 2 over 3. So basically, my sum to infinite is negative 2 over 3 of this convergent geometric progression. And I'm done. Okay. So that is the first example. For the second example, we are basically going to look at finding the sum to infinite, because this means the same thing as find the sum to infinite of these progression if x is equal to negative 3 over 4. The first thing you want to do is make sure you understand what is presented to you. So I know they want me to find this when x is that. So the first thing I want to do is I want to find what is this if x is that. That is basically just going to give me 2 times negative 3 over 4 plus 1 and O to the power n. That is basically what it is. What is that going to give me? It's going to give me a 3. This is negative 6 over 4 plus 1 to the power n, which is just 3, negative 3 over 2 plus 1 to the power n. And what is negative 3? What is negative 3 over 2 plus 1? It's like 1 minus 3 over 2, or rather 2 over 2 minus 3 over 2, which is simply going to be 3, negative 1 over 2 to the power n. So this is your series. So what is this question asking you? It's asking you find the sum to infinite of this. That is what it is in simplest form. So I'm finding this. Now, what is the first thing again? I want to know my first term, I want to know my second term, and I want to know my third term. Why do I need those 3 terms? Because I need to know what A and the R is. So I need at least the first 3 terms. So what is the first term? The first term, I'm going to start when n is 1, then I'm going to go to when n is 2, and then when n is 3. Take note that you can pause the video, try it, then you come and see. So what am I going to do? I'm going to say, okay, so it means the first term is going to be 3, negative 1 over 2. Then I substitute n with 1. Since that's 3, I'm going to add. The second one is going to be 3, 1 over 2, negative 1 over 2 to the power 2. And the third one is 3, negative 1 over 2 to the power 3. So what is that? This is just 3 times negative anything to the power 1 is just that. So it's just that. I'm just doing everything step by step so that we don't leave anybody out. Then I have plus 3 to the power. Then I know this is power this is power an even number, right? So it's negative. So it's basically going to be 1 squared over 2 squared. And that is going to be 1 over 4. Plus, this is 3. Negative 1 to the power 3 is negative 1 to the power 3 is negative 1 over 8. Actually, I did it together. Negative 1 to the power 3 is negative 1. And 2 to the power 3 is 8. So that is basically what it is. So what is this? This is a negative 3 over 2 plus a 3 over 4 minus a 3 over 8. So this is mine. But I know this does not end there. It does not end there for any reason. So I'm going to say, oh, okay, those are my first. This is my T1, T2, and T3. So I have my first, second, and third term. So I can proudly say my first term is -3/2. To get a common ratio, I'm going to say T2 divided by term 1 should give me T3 divided by T2. So what is that equal to? T2 is 3/4. Dividing it with T1 is multiplying it with the reciprocal of that. Remember? Don't forget your negative. And equal to term 3, dividing it with term 2 is multiplying it with the reciprocal of the second term. What is that going to give me? It's going to give me, this is 6, -6 over 12. And this is -12 over 24. What is that? That is -1/2 equal to -1/2. So basically, I can proudly say the common ratio is then -1/2. Please take note, doesn't mean the common ratio is always 1/2. No, just a coincidence. So now that I have my common ratio, I can proudly say that since I know s to infinity is a/1 minus r, now I know what a is. And I know what r is. I can proudly say that. What is that equal to? That is -3/2 over 1 minus -1/2. Once again, is 1 plus 1/2. And 1 plus 1/2 is 3/2. And what is that? This is basically what you're having here is -3/2 divided by 3/2. What is that? That is -3/2 times 2/3. What is that? That is -6 over, that is -6/6. What is that? That is -1. So basically here, you can also get it by using your calculator. Let's just confirm it. What it is that I have -3/2 divided by 3/2, and that gives me -1. So basically, you can conclude and say your s to infinity is -1 for this convergent geometric progression. Thank you for watching. See you in the next video. Don't forget to share, subscribe, like, leave a comment of your suggestions. Motivate me, man. Tell me you need some more. Thank you.